Oh, by the way, for men and women, differences in fingerprint. Yeah, this is about fingerprint quality.
Okay.
And you can also see that most people tend to be right-handed. Actually,
No, left-handed.
well, it is an incorrect conclusion. For many people, I take it all back. There is a slight bias towards left hands producing better quality scans. That's what the graph says. It also says that men are more skilled at it than women are. What else? Quality of fingerprints by age group. So they didn't have data for 25, but they did have it for other categories. Okay, this is about something else. Okay, that's this one. All right. Now, I told you about taking photographs and the overlay, and these dots. So, if it's here, it's a good thing. Now, let's see let me tell you what it says. The shapes that have a border around them are without an overlay, and the one without a border are with the overlay. But maybe it doesn't sound right, so let me. So this one is without an overlay, so is this one. The dark ones are with the overlay. And you can see that when you do have an overlay, they are very, very close to the hot spot, the sweet spot. Yeah. Whereas the absence of the overlay sometimes caused people to make the offset go all the way to the left or all the way to the right, so that's really bad. So you can see how such a very simple thing as a primitive overlay on top of a picture helps you significantly improve the quality of your required pictures. And this is what the end result looks like. And that's something else, again something else. Oh, this is a visualization of the points on one's face, which are taken into account for facial geometry. And these are defined in the following standard up there. It's standard. And you see, they look at the shape of your lips, at the shape of your nose, at the eyes. So there are many factors that play a role in figuring out whether it's you or not. It's also, on this part, you can see that the ear geometry also plays a role. Okay, let's see what else I have here. That's something else. Okay, now we made a full circle. Let me find the slide I was looking for.
That's weird.
Okay, we are getting closer. Almost there. Yeah, this is an old thing. I am just looking for one screenshot. That's it. Okay. So, have a look at this. You have 5 hashes, and you have to tell me which of them are identical.
Which of them are identical?
2 and 4, I guess.
2 and
No,
Second, fifth?
no,
2 and 5.
no, they are.
No, I think not worth.
No, they
They're all
all are different.
Yeah.
actually.
So the correct answer is that all of them are different, but 2 and 5
These
are
both-
deceptively similar. What the attacker did is they made the first few digits
Same.
identical
in the last.
and the last few digits identical, and the chunk in the middle is also the same.
That is a
Because
very common way of.
When you compare stuff, you don't do this byte by byte. You take a general high-level overview, start, middle, end. If they match, then you think it's the same.
Yeah.
So, remember that example about SSH servers when they show you
Actually,
Yeah.
that little digest and you have to compare it. There is a risk that it will look similar, but it won't be similar. Which is why, yeah, there should be another screenshot. Okay, so this is where the differences are highlighted in color. And now, when we've used color coding, it's obvious that they are different. And these are, so the colors highlight what's similar. If it's not highlighted, then it's different. Yeah, this is what it looks like when you SSH into a computer. So it gives you some hexadecimal mumbo jumbo, and they expect me to compare it manually. Not a good thing. And this is that visualization of the key, which I told you about. It's been around for many years now. And I can't imagine why someone would want to disable this. Because this gives you a visual aid. It simplifies the process of answering the question, are they identical or not? So this one relies just on ASCII art. There are other approaches which use much more colorful and shiny examples. One approach you could rely on. Now I don't think we'll need slides anymore. Let me just have another quick look. Yeah, I'm going to turn this off, draw a few more things, and then maybe we have some questions. So what I wanted to show you, actually not show you, but introduce you to the concept of homograph attack. What do you think is the principle of this attack? Well, graph means right.
same.
Huh? Similar. Okay, so you can also call it, some people call it homograph, some call it homoglyph, same thing. Now, here's the example. Let's say I go to paypal.com. So the address, let me use a different color. When I go to paypal.com, my URL bar has this. I can look at it and I can say, yeah, that's the right thing. But you may be aware of this, but not that long ago, a new option was added, and that is to have Unicode domain names. For example, I could have something like, this is in Russian, Россия РФ, I think, Российская Федерация. So this is a Russian domain name, and you can observe several things. A Russian O looks exactly like the Latin O. A Russian S looks like a Latin C. A Russian R looks like a Latin P. So what I could do is I could make a URL that is not PayPal in Latin, but it's R-A... Oh, by the way, this looks like a Russian U. So U in Latin is this in Russian. So I could make an analog of PayPal. The only character I don't have in the Cyrillic alphabet is this L. But because it's Unicode, I can make it like this. So this would be, I'm now reading this as Russian. R-A-U, R-A. Now this is a Latin L, and this would be S-O-M. So it looks just like this one, but fundamentally it's different because these characters are different. What you have so far is, you've seen this with phishing. People do the same thing. For example, instead of, let's say there is a bank called Bona. So the domain would be bona.com. I could sign up for another domain, call it b0ma.com. To the untrained eye of a grandmother, they will be the same. And if I was clever enough to make my site look exactly like the real thing, this would be a successful phishing attack. Now, you can say, okay, I'll just be very careful when reading my URLs, and now the problem is resolved. The problem is that it's not. As soon as these Unicode domains become mainstream, this would mean that there are many ways in which I could, so there would be many domains that look like PayPal.com, but are essentially different. And now, even if you have a trained eye, even if you know that phishing is out there and the bad guys want to get you, there is no way for you to double check. There are several solutions. You could, if the URL is proper, I mean, if they were smart enough, they bought a certificate, so it's HTTPS, you can click on it, and you can view the information about the certificate. You could see that it was issued by someone, it was issued to company so-and-so on date such and such. And you could also have, as in that case, you could look at the thumbprint of the certificate, some unique set of numbers, and then you could memorize that PayPal's numbers are these. So always, whenever you go to your PayPal account, open the certificate, check out this line and compare it with the one you've had. But as I've shown you in that slide, even if I put two hashes one on top of another, there is a chance that some people will miss the fact that they are different. So one idea could be this. You could have, remember this visual thumbprint? You could take the domain name, the high-level domain name, hash it along with the data in the certificate, and draw a little picture, like the ones which I showed you, with colors and more sophisticated shapes. And you could take that little picture and draw it in the browser's URL bar next to the URL itself. And it would look like, let's say, it would be half blue, half green, and it would have some curly shape in it. So whenever I go to this website, if I see this shape that I recognize, then I can say, okay, that's the right thing. And if I go to another one, which looks the same but is different because they actually used Unicode characters that look like the ones in the original, then this picture would be different. Because even though the letter is the same, but
the Unicode,
the code that corresponds to it is different. It's easy for the computer to notice the difference, but it's difficult for the human. Which is why we take this problem and reconsider it. We turn it into a visual problem.
So this is mostly done to prevent phishing attacks.
Yeah, you can use this to prevent phishing attacks in a much more effective way than.
But one could argue that how often do people, after entering the URL, look back at the URL on the site? Because what people usually do is enter the URL, hit the enter key, and just wait for the page to load. And they don't look at the portion next to the URL where you could display that kind of image.
This could come in when you're logging in into the system, right? I mean, when you're logging in, like how banks have.
So there are several ways I can answer that. First of all, if you use some kind of a service to pay bills or to buy stuff online, it's the same service all the time. So either way, you have to type the URL, and you will memorize this picture.
Right.
It's not like I'm going to use PayPal today and then never get back to it in 1,000 years. That's not the case. What usually happens is I use it maybe a couple of times per month. So whether I want it or not, I will be exposed to this little drawing, and I will memorize it, because memorizing pictures visually is much easier than memorizing such sequences of arbitrary characters. So that's one thing. And second, you could take into account information overload and change the design of the system such that people won't even have to think about it. Now look at this. You could have the following approach. Let's say I am going to PayPal, and the browser knows that last time I visited this site and everything was fine. The IP address was blah, blah, blah. The certificate was the one that had this thumbprint. And the browser could do the following. If I go to the same site and somehow the IP is different or this is different, then it shows me a warning that indicates that you've been here before, but this is not the same thing anymore. In other words, the browser will only let me know about it when it matters.
Right.
Whereas what we have today is you have this padlock icon and HTTPS and all that stuff is always there. And because it's always there, then you just become immune to it.
Yeah, that's what.
And one day when it actually matters to pay attention to the little icon, you don't. With the method I just described is different, because it removes all the distractions, it lets you focus on whatever you want to get done, and when something important happens that requires your attention, then we make it obvious that something is different. Another thing we could do, for example, the browser could memorize. Assume that we would have some kind of a table of equivalency that would say that the English character A, C, okay, let's just have the whole list of letters, A, B, C, D, blah, blah, blah. And then you would have, for example, for Russian, and it would map the ones that look similar. For example, A looks like A, this one looks like the Russian symbol, and so on. And then the browser could do the following. If the URL because the browser knows it not just as a letter, it knows the code behind that letter. It will then see if any of the letters present in this domain are also present in this equivalency table. And if they are, that's a sign of the fact that perhaps you are on a site that relies on the homograph property to trick you into revealing some credentials.
So basically this is homographing. I mean, you
Yeah.
have a different Unicode or something like that. That's homographing.
So it's the same for us, but still the computer can see the difference. And computers are very good at comparing bytes, adding numbers, subtracting numbers. They do this all the time. So why should we place the burden on people like they did in that policy? You know, you could write a policy that says, you shall always check the URL bar or something of that sort. Or you could just design the software in such a way that it prevents these things from happening. So what I hope I managed to convince you today is that there is a lot of power in your hands as programmers, much more than you think you have. And unless you think about the user's perspective, then you may not use that power fully. But once you become aware of all these things that can happen, then you have more insight into choosing better designs, into making better choices, etc. So these were the examples for today. Maybe you would like to add something, or maybe you have other examples that you've seen in different programs. I can bring up another one, also related to websites and HTTPS. Maybe you remember that years ago, if it was HTTPS, then it was just that. Then, the bad guys realized that I can buy a certificate, I can set up a different domain. Yes, it will have the padlock icon, it will be green, but it will be a fake site. So what HTTPS implies is that the connection between me and the server is encrypted. But it doesn't imply that the server is really PayPal. Unless I open the certificate and I carefully examine it and I check the thumbprint and somehow I know that PayPal's thumbprint is that one. Once I do this match, I'm safe. So in the beginning, people who develop browsers, they just show the green padlock and no padlock. The bad guys would buy a domain, buy a digital certificate, set up HTTPS, and then people would go to the site, they would see the green padlock, and that would be interpreted as, oh, it's a trustworthy site, let's go for it. But that didn't work out. So what happened then, and this is what we have to this day, if you go to a website that uses HTTPS, but the certificate was self-signed, that is not issued by some higher authority CA, then you would have this huge full screen warning with a red background, you know, like in Firefox.
Yeah.
And it has a lot of text in it, some buttons, you have to add an exception. So that's one way they solved this problem.
How did they do it? I did not understand. I'm sorry.
So you go to a website that has HTTPS, but the certificate used in this HTTPS session was not issued by a certification authority which your browser trusts by default. So these certificates are called self-signed certificates. So when the browser stumbles upon a self-signed certificate, it says, oh, wait, stop. And it shows you this red border, and you have to manually indicate that I trust this certificate.
Basically, because people don't go and look inside each certificate, so the attackers
Yeah.
tend to take advantage of that.
So that's one approach. I'm not a huge fan of this approach because it makes me do extra clicks, it interrupts my workflow. I was doing this and now suddenly this whole thing is red in front of me and I have to do something else. And that's me, a guy who studies security and knows how things work. But one thing I think you should definitely take away from today's meeting is the mother test. Or if you have a sister, then they call it the sister test. And the test is as follows. If I see some kind of an interface, or if I design some kind of an interface, and I see that people don't like it, or they find it unusable, as a programmer, when I read those bug reports, I feel somewhat insulted because, you know, it's my work and somebody criticizes my work saying that it's completely unusable, unclickable, blah, blah, blah. And you may have noticed that many programmers are arrogant. They call users stupid, idiots, and you have all these things like problem between computer and between keyboard and chair, other ways of insulting users. So one way to prevent that is to think about your mother and ask the question, if my mom used this interface, would she also be the type of person that I would call stupid? And of course, I would never call my mom stupid. This implies that the interface sucks, so I have to think of a way to reconsider it before calling everybody else stupid. Because if you have hundreds of people telling you the same issue, yes, you can say that people are stupid, but maybe there's something you can do to change the interface such that the problem doesn't exist anymore. So the mother test is something you can rely on, you know, as a thought experiment before calling anybody stupid, before saying, no, I am not going to change this interface. Think about what your mother would have done if she ran into this interface. If the answer is, well, she would be confused, then obviously you need to do something about the interface. Do you have, what are your questions? Any of them?
We cleared it with the, as we were going, I think, right?
Okay, then thanks for joining me today.
Thank you so
And
much.
I can make a list of the books and articles and stuff I mentioned today and send it to the mailing list. So you could,
That'd be good.
yeah. All the books that I mentioned, I've read them, and I have them in paper format or in electronic format, so if you want them, you can have them.
That would be nice.
You read all the books that you talked about.
Yeah. So this is something I distilled as a result of reading this stuff. It's not that I went to a site, read these keywords, and then just draw this thing on the whiteboard.
Thank you so much.
Thanks a lot.
Thank you.
Thank you so much for your time.